So we're looking at an ellipse whose center is no longer at the origin. Where is it now? What would our center be for this one?
2, 1.
Good. The center is 2, 1. And kind of the nice thing about the center is it works the same way that it worked with circles. It worked the same way that it did with the parabola. X is always with H, Y is always with K, and it's always the opposite of whatever that number is. Now, Ethan, is this going to be a horizontal or a vertical ellipse? Good. How did you know? Okay, so if a squared is 25, what's our a value?
5.
Yep. Okay, so that means b squared is 4, so b is going to equal 2. Good. Now, Tiffany, what would c squared be? 21. So then what is our c value? Good. All right. Everybody okay with what we got there?
Yep.
All right. Now let's take a look at graphing this thing. Where should we start at?
Your center.
Your center. Good. You have to start from your center. 1, 2. So over 2, up 1. And I'm going to label that as being my center just because we're going to end up with lots of points everywhere. Now, our major axis is going to be not so much like the x-axis or the y-axis now, but is it going to be horizontal or is it going to be vertical?
Horizontal.
Horizontal. Okay, so horizontally, I need to count how many from my center? 5. So I'm going to go 1, 2, 3, 4, 5. And what do we call that? It's one of our vertices. Good. And then you'll also go 5 the other direction, to the left. So 1, 2, 3, 4, 5. And there's our other vertice, or vertex. Tim, are you okay with how we got that?
Yep.
All right. Now, as an ordered pair, Tiffany, what is this vertex over here?
5, 1.
Not 5, 1.
7.
Good, because we started at 2 and went over 5, so it's actually going to be 7. One of our vertices is going to be 7, 1. And then the other one, Vanessa, if we go 5 to the left, what does that put us at?
-3, 1.
Good. All right, so those are our vertices. Let's talk about our endpoints for our minor axis. Starting from your center, how far away do you need to go to get your endpoints for your minor axis? 2. So we'll go 2 up and 2 down. So Lexi, if you are asked to find the endpoints, and tonight's assignment is a worksheet, so I think you are asked to find them, what ordered pair would you write down for your endpoints?
2, 3.
Good?
And 2, 4.
Good. Nice.
And then do we need to include our focus?
Good idea. Okay. And do we just have one focus or do we have 2?
2.
2, so it's going to be our foci. Now, this square root of 21. Normally, when we were at the center, we were just like, okay, so I go that far this way and that far that way. Are we still going from the origin, though?
No.
No. Okay, so we need to add the square root of 21 to our center. What is the square root of 21?
4.58.
4.58. So if I go 1, 2, 3, 4.58, so about halfway there. And then 1, 2, 3, 4, 4, so I'm going to say it like that. Okay. Now, since that's not a nice number, like that's clearly going to be a decimal, the way that we're going to write our foci, we took our center point, and did we add to the x value, or did we add to the y value?
To the x.
The x, so we're going to write it as x plus or minus the square root of 21, comma. Now what, did the y value change on us at all?
No.
It's still what?
4.
Good.
And that's for both?
That's for the foci, yeah. If you wanted to write it as 2 ordered pairs, you could. You could write 2 plus the square root of 21, 1, and then 2 minus the square root of 21, 1. Okay. Tiffany, are you okay with how we got our vertices, our endpoints, and our foci? All right, Ethan, what would the domain be on this?
Bracket, -3, comma, 7, bracket.
Good. And Vanessa, what would our range be?
Bracket -1, bracket 3.
Good. There we go. Tim, same shape, we're just different center. Is that all right?
Yep.
Sounds good. Okay, let's do another one. Oh, wait. Did we? This is a different one. Let's do this one. Lexi, is this one in the correct format?
Yeah, I'm not sure what's going on right now. Honestly.
Did your music just start?
Yeah.
Okay,
And
that has
it
happened to me
wasn't
before.
You know.
on play.
Like it just randomly started playing.
Interesting. Do you want to like turn it off?
Yeah, that's probably
Okay.
in case it starts doing it.
That scared the crap. Because like I was at work, like helping a customer, and they were like, "Do you hear that?" And I was like, "Nope,
Nope.
nothing."
I don't know what you're talking about. That's exactly how I would have played it. I don't know. All right. So back to this. Lex, what I was going to say is it written in the correct format?
Yes, it is.
Okay, so we don't need to change anything around. Like we don't need to divide by anything. It's already set equal to 1. We've already got it in the like x minus h squared over whatever we want it to be.
Which that's not going to happen on the homework tonight. For most.
Or on the next example.
Oh, okay.
Baby steps.
Well, I felt like you're gonna just jump to it real quick. But.
I thought we'd do one more where it's set up nicely. Tim, is this going to be horizontal or vertical?
Vertical.
Good. So what's our a squared value going to be?
There's 6.
Okay. So we're dealing with a vertical. And, ooh, let's talk about the center, and then we'll deal with our A's and B's and C's. Tiffany, what would our center be on this ellipse?
-3, 2.
Very good. -3, 2. All right, so then b squared is going to be what?
16.
Thanks, Ethan. Okay, so b is going to be 4. Vanessa, what is c squared?
2 squared of 5.
Well, it's c squared.
Oh, sorry, 20.
Okay. And then that gives us our c value being 2 square root of 5. I agree with that. All right, excellent. I find that it's easiest to graph it and then tell what the vertices, the endpoints, and the foci are, because it's just visual. It's helpful. All right, so we'll start at -3, 2. So here's my center. Since this is vertical, go up 6, and you gotta go up, so you also have to go down. Good. All right then. So we're gonna go up 6, and we're gonna go down 6, and I'm gonna find my pen. Found it. So we've got 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. Good. Okay. Okay. So for my vertices, I go based off of my center, but then does it change the x value or the y value of my center? The y value. Good. Okay, so this point up here, it's still -3, but now it's comma what? We were at 2. 8. Good. Okay. So we started at 2, and then we went up 6. So 2 plus 6 gives us 8. And then my other vertex, still at -3, but then we subtracted 6. So what would 2? -4. Good. Okay. So there's our vertices. To get our endpoints, Tiffany, how far left and right do I need to go?
4.
Good. So 1, 2, 3, 4. And then 1, 2, 3, 4. All right. So we added 4, and we, oh, that is a nice brace. Okay. So for our endpoints, starting from the center, do we change the x value or the y value? The x, okay. So if we start at -3 and add 4, where does that put us at?
-7, 2.
If we add
1,
1, 2, and then let's, yeah, the other one would be -7, 2. Good. And yes, we still need to do the foci. Trying to erase without erasing the good stuff, my points. Oh, this is going to be tricky. All right, so. There we go. All right. Now for your foci, we add it to the center. Will it change the x or the y on our center?
The Y.
The y, very good. Okay, so for our foci, we're going to say that it's still at -3, but then 2 plus or minus 2 square root of 5. Tiff, you want Snickers, M&Ms, or peanut M&Ms?
Anything besides peanut.
Oh, gee, that's too bad. Here you go. Tim, how about you?
Don't matter.
Oh, you also could have had a Twix.
It doesn't.
All right.
I'll take a Twix.
All right, there you go.
Snickers, please.
You got it. Here you go.
What are my choices?
Peanut M&M, regular M&M, Snickers, or Twix.
I think I'll do Snickers.
All right, there you go. Get the protein. That's what I tell myself.
M&M's.
Regular?
Doesn't matter.
Okay. Tim, what would the domain for this be?
Is that -4? Bracket -4.
All the way over here.
Oh, domain, bracket -7,
Mm-hmm.
comma, 1.
Go ahead. Tiffany, what would the range be?
Bracket -4, comma 8 bracket.
Good. Nice. Everyone feel okay about all those? Okay, so now let's look at one like this. Mm-hmm. I like to be dependable that way. All right, Vanessa, what do you reckon we might do first here?
Divide by 144.
Good, divide everything by 144. Divide by 144, divide by 144, divide by 144. Okay, now can you reduce 9 and 144?
Yes.
What?
116.
How about, oh, 116. I thought you were saying like 116. I'm with you now. Okay, so our equation is going to look like x squared over 16 plus y plus 3 squared over 9, good, equals 1. Tim, do we need to do anything else to put it in ellipse format?
No.
No, that looks good to me too. Tiffany, is this going to be a horizontal or a vertical?
Horizontal.
Good. I'd like you to try this one on your own. See what you come up with.
Oh, did you unpause it?
Yes, I did. Thank you. my information that I got. See if it's also what you end up with. Not really.
I don't know if graph include versus in the graph or
Just listing the amount written down. I'm happy if you just have it written down.
So, I just read it, but minor axis.
The endpoints of the minor axis.
Oh, okay.
It's,
I thought it was asking for all of that.
I ran out of space typing here, so dropped it to the next line.
Okay.
Yep, but it's saying the endpoints of the minor axis. Oh, I need to include my domain range. One, two, three, 4. Excuse me, and 4. And then my range. -6, 0. Okay.
It wouldn't be incorrect to say 0 plus or minus square root of 7, would it? Okay.
0. What? Oh, yeah, I get what you're saying. Yes, that'd be fine. I was thinking you meant 0, comma, plus or minus. No, that would be okay too. I just left it off because it's 0. Lexi, did you have a question, dear?
no, I figured out what it was.
Okay. Tim, question?
No.
All right. Tiff, you good with that? All right. Ethan, you're good? Okay, so this is where I want you to go back and we're going to be a little bit more detailed. So like on the horizontal ellipse, okay, your center is h comma k, and then your vertice is going to be your x value plus or minus whatever you get for a. Your co-vertices, that's the same thing as your endpoints. Co-vertices are the same thing as the endpoints, or where you change the y value. So that's your k plus or minus b. And then your foci is your x value plus or minus whatever you got for c. Subtracting a to the y value of your vertices, to the x value for your endpoints, and to the y value for your foci. So this is just kind of summarizing what you add and subtract to get from your center to get all your other stuff. let's take a look at a really fun one. Let's take a look at this one. I want to do one like these together, one like this together, and then I'll actually have you like be up on the boards. So is this one written in ellipse form?
No.
No, clearly not. What are we going to need to do? We're going to need to complete the square. How many times? Twice. Good. All right, so I'm going to put my x's by each other. I'm going to put my y's by each other. For right now, do I want that 3 there? No. Okay, I'm going to kick it to the other side. So that's going to look like x squared minus 6x plus blank. Now, Lexi, since we're doing it twice, do you want to do plus blank minus blank, or do you just want to do a plus blank on both sides of the equal sign?
Let's just do a plus blank.
Sounds good. Okay. And plus 4y squared plus 8y plus blank equals 3 plus blank plus blank. Okay. All right. Now, the x is good to go. What do we need to, all right, to complete the square, what would we put here?
Negative 6 over 2.
Which would be?
3.
Negative 3 squared. And over here on the right-hand side, how am I going to write that?
9.
9. Good. For the y's, can we just divide by 8 and square it?
No.
Why not, Vanessa?
Because there's a 4 out in front of them.
There is a 4 out in front of it. Okay, so what we're going to do is we're going to take a 4 out of just the y squared portion of this. So this is going to look like y squared plus 2y plus blank. Is everybody okay with why we had to take a 4 out?
Yep.
All right, now Tiffany, when we complete the square there, what number goes right here?
1 squared.
1 squared. Now here's the tricky part. Am I just going to put a 1 here?
No.
Well, no. What's going to go there?
4.
Very good. Is everybody okay with why it's a 4 on the right-hand side?
Yeah.
Okay. So, Tim, factor all those x's down, please. What's that going to look like?
X minus 3 squared.
Good. Ethan, I've got that 4 there, but factor down the y's, please.
X plus 1.
I'm going to go with y. Good. And then, Vanessa, over there, what does that all equal?
16.
16. Okay. Is it in ellipse form now?
No.
No. What do we need to do now?
Divide it all by 16.
Good. Divide everything by 16. Just as a what if you had done all of this and you ended up with it being like that? Would that still be an ellipse?
Yeah.
No, what would it be?
Circle.
It'd be a circle. Huh? See how there's no number in front of them? When there's no, I'll say coefficient in front of the parentheses, then it's a circle. But since there's that 4 there, we know it's going to be an ellipse.
But if there was a coefficient in front and they were the same number, it'd still be a circle, because it'd reduce the same.
Fact. All right, so we'll divide everything by 16. Okay. So this is going to stay x minus 3 squared over 16 plus y plus 1 squared over 4 equals 1. And after that, it's just the same as what we've been doing, right? Okay, I want to do some practice problems, so go ahead and find a spot on the board, please.